Hello, you guys. This is Nick, and today we're going to talk about air conditioners. So let's get started. First of all, air conditioners are simple. You may think it's complicated, but if you take a little time, study this little drawing I'm going to do, perhaps it can help you understand how what things are happening. So first of all, we start off with 220 volts. AC. All right, and it comes in from the fuse panel, and located very near the air conditioner is called what we call a fuse disconnect. All right, so the voltage goes through the fuses, and if the fuses are good, the voltage passes through here. So the first component that you see is a transformer. Now, what a transformer does is kind of what it says it does. It actually transforms the 220 volts down to 24 volts AC. Alright, and then the first thing it does, it passes through a safety pressure switch. This switch is located in the air conditioner unit, and if the pressure gets abnormal, it opens the circuit. So this is a pressure switch. That's right here. And then the next thing it does is it goes to a thermostat. And a thermostat is simply a switch that when the temperature gets too hot, this switch closes and it tells the AC to keep going. The next component located in the air conditioner unit is a relay. And the relay is just an electromagnet. All right, and its function is that when the unit is to run, this relay energizes and closes these switches. So the power, when the air conditioner is to run, the power proceeds down the circuit through the relay, which now it gets closed, controlled by the thermostat. There's one additional safety device located in here. And this is another switch, and this is a thermal overload switch, a thermal switch. And this guy is located on the compressor, in contact with the compressor. So the voltage proceeds down through this thermal overload switch to the actual compressor. And there's one additional component, which is the capacitor. It's connected to the compressor. And that's this guy right here. Of course, there's one additional big unit in here, which is the fan. And a fan normally also has a capacitor connected to it. So let's kind of review what happens. Okay, the 220 volts come in. It comes through a couple of fuses. All right, and then tied off of that, it comes into a transformer. The transformer converts the 220 volts AC down to 24 volts AC. All right. The circuit then proceeds to a pressure switch. All right, and if things are normal, This switch is closed, so the voltage now proceeds down to the thermostat. When the thermostat says the temperature is correct, it closes a switch which powers up a relay. The relay then closes the high voltage switches in the compressor. So now the 220 volts proceeds down through the relay toward the compressor. There is one additional switch between the relay and the compressor, and that is a thermal overload switch. This is usually a round device about the size of a silver dollar that's thermally connected to the compressor, and when it is cold, or not overloaded, the voltage then proceeds to the compressor. At this point, the compressor will start to hum. If the capacitor is bad, the compressor will hum but won't start. So that's kind of, if you get a humming over here, and the thing is this compressor is not running, that's an indication that you got a bad capacitor. In addition, the fan is tapped off ahead of the switch, so that, and it also has a capacitor, and you can identify the capacitors because they're typically round and about 4 inches, and of course this will be about twice the size of this one. So if the fan runs and the compressor doesn't turn on, it doesn't run, it could be an indication that this thermal switch is open, and they do go bad occasionally, or this capacitor is bad. So guys, that's the story, and good luck. Call me if I can help you.